Technology course, I have also recently uploaded some walkthrough examples for you to try out as a preparation for the final exams and other things. So the final exams, you will have like short objective type questions, true or false questions, and a few numerical problems like in the walkthrough examples and other examples that were given in the class lectures. So yes, let me know in this meeting if you have any specific doubts or queries regarding the course so far. Now that we are near the end weeks of the course, yes, I will be happy to take up any questions that you have. Anyone have any questions?
Sir, did you allow me? This is Manala.
Yes. Yes.
Thank you, sir. I have concern about ethanol fuel. Yeah.
Okay.
The blend is up to 20%, but in Brazil they have a flexible engine which accommodate up to 85%.
Correct.
They call it flex engines. Yeah.
Yes.
Is India developing flex engine? In India, there is a development in building or fabricating a flex engine. Is that possible?
Not that I know of. It's certainly possible. Brazil has done it, but I think we do not have the volume production of ethanol yet here that justifies the investment into flexible engines. There has been a new biofuel policy that tries to increase the blending percentage of ethanol and biodiesel in existing oil and gasolines and diesels. But I am not sure whether flex engines is part of that program yet. Okay. So far, biodiesel development has happened, but the scales required to get up to even 20% is not there. So we are hoping through this new kind of policy, we can improve the blends to 20-25% for the conventional engines. But I am not yet, haven't heard of any attempts to do flexible engines till now among the automakers that are here.
Okay, thank you.
Yeah.
I wish others to participate. That's why because
yes,
when I was watching the videos, I feel happier. You demonstrate very well. By the way,
thank you.
That is, I appreciate. That's why I'm just joining now. Also,
yes. Yeah. Please.
The way you explain things, or maybe beautifully. Thank you very much.
Thank you.
Last time also I repeat. I'm watching.
Yes.
By the way, I have another question also because I'm just with attending properly there. One of the cues it says that geothermal, basically, geothermal energy has no significant maintenance space. In that, I need clarity because I start to study with that. Okay, in terms of, I just try to see initially investment cost is high because corrosion resistant material is required, expensive, but in operation it is low. All the journals says they have low maintenance and operation. That is the justification for recommending geothermal power. But on the key, it says it doesn't have significant. In what perspective?
Okay, I need to look into the maintenance aspects a little bit more detail. Some materials I got was that because of the high, like the salt content of geothermal fluids, there is an issue with the maintenance of the specifically those parts that are getting in contact with the geothermal fluid, like the filtration systems and the like the piping systems, etc. But I need to check whether that is a significant concern or not. I understood as much that the maintenance is slightly higher than normal steam power plant kind of a system. Yes, that of course, here we would say that the maintenance compared to say a solar or a wind turbine is would be higher, right? So at least that much is clear. Of course, what are you comparing it with is the question in that case, right? So I need to check what the relative maintenance costs are for a geothermal power plant compared to a standard coal power plant. Some of the drilling systems, of course, will require a little bit more maintenance, right? Because the geothermal fluid itself is a bit corrosive and difficult to handle. But of course, it's not significantly high once you do the proper installation and everything. That I agree. So if you invest in high, good quality materials, then maintenance will be low, certainly.
Yeah. Okay. Thank you very much.
Yeah. So I received a question from Jay in the Excel sheet that why power generation from wind farm is considered as peaking power, but it is not reliable power. So I think you are thinking more of like whether it's a base load power operation versus peak load power operation, etc., or a cycling power plant operation. So one of the reasons is because wind power is inherently intermittent, so it cannot serve as a base load power plant. Okay, its capacity factors, etc., lower, availability factor, etc., lower. So of course, all renewable energy technologies can serve the base load or the cycling load power plant capacity situations if it is connected to a proper energy storage technology system that is able to store the power or improve the quality of the delivery in its various functions, right? So one of the motivations of looking at the energy storage technologies and its various applications within the power plant was to increase renewable energy penetration, that is transition wind and solar based energy sources from just peak load power plant operations to base load or cycling power plant operations, right? So without such modern storage systems that take care of the intermittency effects, both short term and long term, you cannot do that. But with that, yes, you can do that. So that transition is possible.
I think, sir, no one was
Yes,
there.
we will. Yeah, I will wait till 3:30 because students can be available later also.
Okay,
If
okay.
you can choose to be here or you can also go. Thanks for all your feedback and questions. So,
Okay, thank you very much. In the meantime, can you give me an opportunity to ask regarding my study area, some
yeah,
related to energy, just
yes,
to get an advice.
yes,
I am doing a PhD at Amrita University,
okay,
sustainable energy. My background is mechanical. That's
hmm.
why I'm just joining this class. But I am planning to initially to investigate village needs, how the
Okay,
villagers needs. After that, I will devise an intervention, basically energy related intervention that will solve community problems. This is my area of interest. But I'm
okay,
thinking, I'm just as brainstorming. I'm conducting some surveys initially. Okay, someone is joining. He may have a question in the meantime. Yeah. Then
you can continue your questions and we will, yeah,
okay,
no
okay.
issues.
Then in between, what I'm planning is I found that as primarily, then I need to confirm with that as primarily there is a cooking energy demand. The villagers needs energy for cooking. I wish to devise a system that will compress biogas as well as then distribute for the villagers. That's what I'm thinking. How? Because by compressing a biogas by itself, self-ignition temperature there, carbon dioxide removal system there. I'm thinking about this. Is there any development around this one in India? Because packing biogas and distribute for the villagers is one alternative. Currently, they are facing high cost of LPG. This is my area of, but I need confirmation from my advisors after data collection.
No, it's a promising idea of using biogas as a cooking solution. And there are several stove technologies that exist already, which are which can use biogas effectively, either pure or in blends with LPG. I think the main issue of where the trouble comes in terms of making it economically feasible. So, for example, again, it kind of depends from country to country. There are several startups that are now coming up in India. I'm aware of that, which are looking at the supply chain aspects of collection of waste, agro waste, and how to convert that into biofuels or biogas systems. So if the collection can be done efficiently, collection and sourcing to a central facility that is converting this into biogas, then many of the issues become resolved, because it's kind of a dilute resource you have to collect from individual farms and like that. So there is a lot of work that is going on how to incentivize local communities or villagers so that they can collect it and in a way that is easy for us to centralize. Yes, centralize and deliver to a central facility where then it can be used for many different applications, whether it's a biogas application for local cooking needs or conversion to biofuels for global supply chain, whatever the need may be. So that aspect, if it can be resolved to create more economically, then I think this can really take off. So that's my assessment of where the situation is right now. The other thing is, of course, you have to have a standardized method for a biogas production, because different types of agro waste will have different composition. So if one method that works for one type of agro waste or forestry waste may not work for another type of agro waste. So the sugarcane bagasse system may not work well with rice husk system, all right. So another topic where people want to do is a process that works well for with flexible biomass systems, that biomass to biogas conversion or biofuel conversion, where you can make it more flexible. Especially for biogas, it's easier. Biofuel is difficult. So in that context, biogas may be more useful in conversion process, especially for multiple types of agro systems.
Okay, thank you very much.
Thank you.
Sir, good afternoon, sir. Can you hear me, sir?
Yes, I can hear you.
Sir, there was a question. I lately joined due to my network problem. There was a question in assignment number 8.
Okay.
The question was like that. We have a wind farm system with capacity oblique power operating factor of 20%. Okay. Which type of power plant function is most suitable for?
Okay.
Cyclic plants, peaking plants, base load plants, distributed grid. So, sir,
yes.
I opted for distributed grid. In one of the lecture, you said wind farm is not being reliable, so I thought it should be distributed grid. But the actual question answer is a peaking plants.
Correct.
Can you explain, sir?
Yes, I can explain that. So,
Yeah.
Wind farm is usually a reasonably large capital intensive investment, right? You need large turbines, etc. So distributed grid does not work that way. Okay, you require small scale, small capacity power systems. So wind farms are not very good with distributed grids. What we showed was because of the high intermittency of wind farms in general, it works best with as peak load power plants because most renewables, if it's not connected with strong energy storage technology, is usually enters as peak load power plants, where when there is a significant rise in demand, then that power gets into the system. Okay, and that kind of also has makes it possible to deal with its intermittency issues because you are using it for lower amounts of time. So most renewable energy technologies like solar and wind that is going on currently, because the penetration is lower, they are being used primarily as peak load power plants. Okay, so especially when demands are high, you use that power plant to deliver the electricity.
But sir, wind and solar itself not reliable. Without storage, how we can meet the peak load requirements? It should be associated with
there
with
will be some storage options, but if you look at the characteristics of a peak load, its availability factor and capacity factors are lower, right? So it cannot actually work as a base load because over an entire year, the wind farm will not generate sufficient electricity to run as a base load system. Okay, so with renewables coupled with storage is used currently as a peak load power system because that's where its capacity and availability factors are at.
Okay, so means 20% capacity operating factor. It means association with some storage or not? It's implied.
It will
like
have
that?
some storage. Otherwise, you cannot use it integrate into a grid at all. Okay. So that is also one of the reasons why you cannot use in a distributed system as well. Because in a distributed system, you do not have that luxury of adding a lot of storage to improve the quality and everything. If you are that way, renewables connected with storage is good right now for peak load power plant operations because its overall availability factors are lower.
Okay, sir. Right, sir. Thank you.
Okay.
And a second question, sir, in this assignment, nine, it's this gas power plants. It's not gas, compressed air power plants.
Yes.
Yeah, sir. Is my question is like that? Whether normal gas turbines cannot be associated with some storage of air, like compressor. We can install air compressor and store at that plate only, instead of opting for
I don't understand your question. Can you be a little bit more clear what you are saying?
Sir, in the lecture number 9,
yes,
for compressed air plant, gas plant, it's a base plant. Storage of the air is being done inside the earth in some cavity or like that.
Yes, correct.
So that is a very rare scene. I don't think in India it's possible. Any location is there where we are storing air inside earth.
Not in India, but there are several plants that do work worldwide that way.
So instead of that, cannot we design big tanks associated with existing gas turbines? So we can, when gas turbine load is less in any industry, so that power generated can be used for compressing the air and storing at the site only.
You can do that. It increases the cost, however. So if a natural cavern is present, then the cost of the compressed air storage facility is low. If it's not present and you want to create large containers to store that much air, then it becomes a little bit difficult. So that's where the issue is. It's costlier.
Any
So-
pilot plants are been done in this thinking? Any pilot plant is in India or any R&D at this stage
with
only?
a storage tank.
Yeah.
Are you saying
Yeah,
that?
with the storage tank. Yeah.
I need to check that. Let me just check once.
Okay, sir.
So there are currently two large-scale compressed air plants that uses salt caverns, one in Germany and one in US. Okay.
Right, sir.
Let me see if there are any new plants that are using the system you are mentioning.
Yes, sir.
Okay, so what I understand right now is that
Yes, sir.
when you are using tanks to store, you do not store compressed air because the cost is too much. What you do is liquefy the air by using cryogenic cooling and then use that cooled air later.
Yeah, definitely, sir. By any means.
That will decrease the volume.
Yeah.
So currently there are no plants in operation like that, but there are some plants that are being installed right now. So their construction is currently ongoing for some liquid air storage based plants. And there are several other plants that are coming up with this compressed air in salt caverns for the adding to that idea. So those are the two options that are going on right now.
Okay, sir. But India, there is no such location, no, sir. Where
Nothing
we
in
can,
India. Nothing in India. No.
where ONGC
Nothing.
has having our own fields where they are extracting gases and all. It is possible, sir. Any location in India?
I have to
And
check. I have not actually checked the possibility in India. But
Yes,
you
sir.
can see, if you are interested, you can look at that. I don't myself know at this moment what is the situation. Most of
right,
the
sir.
things I am seeing is like in US, Germany, and other places right now.
Many places
One
are
plant is,
carbon. They are
sorry?
keeping many places. They are decarbonizing the flue gases and putting carbon inside the earth. Many places.
Yes. In your last week's lecture, I will cover those technologies actually.
Okay. Right, sir. Thank you, sir.
Yeah.
Sir, may I ask here?
Yes.
If they liquefied the gas, almost the temperature will be reduced using a refrigeration system.
Correct.
So in the gas turbine, we need also high temperature to improve the efficiency.
Yes, I am seeing liquid air plants coming up. I'm not entirely sure what's the cost and the efficiencies are. I just gave the information because I saw some news items there. But yeah, I am also a little bit skeptical of how that can work. So I am with you on that.
Okay, thank you. May I ask, lecture
Yes.
8,
Yes.
lecture week 8, slide number 5 on application of storage system, utility something, starting
Okay.
from utility grid. And the last one, it says, let me open it. It says about non-energy application, non-energy uses. The fifth application of storage.
Okay. Yes.
Non-energy uses, please. If
Non-energy uses. Correct.
Yeah, I am doubting with the term non-energy use. In a sense, as an example there, battery for laptops, that is energy by itself.
I
Yeah.
understand. I was talking more about using it in terms of
Power
large
production.
scale energy storage, power production, transportation, like that, not the electronics. I understand electronics is a form of energy storage only. It's just in the
Yeah.
energy production distribution system, it's not being used. So that way I was talking about.
Okay.
Yeah. But yeah,
Yeah.
it's an unscientific classification. But when you are looking at energy industry, how storage is
Yeah.
used in terms of energy industry, those discussions do not come up. So that's why.
Okay.
Sir, can I ask one more question, sir?
Yes.
Sir, the question was in assignment number week 7, assignment 7.
Okay.
And question was like that. Cellulosic ethanol can be more sustainable than bioethanol. Sir, how, sir? I couldn't correlate. True.
Hold on.
But
which problem? Which question number do you remember?
question number 11, assignment number 7. Week 7, assignment 7. Week number 7. Question number is 11.
So here bioethanol basically means ethanol from sugarcane or traditional methods. Those are usually, of course, cellulosic ethanol is a part of ethanol, is bioethanol itself. But here, when we are saying bioethanol, we mean ethanol from sugarcane or that corn-based ethanol systems.
So first generation,
Yes.
I think so.
Yes.
Cellulose is second generation. So second generation is more sustainable.
Yes.
Yeah, I think. Yeah.
So, sir, cellulosic, both are cellulosic, sir, na? Either
No,
it is
no.
from first generation or second generation.
No. Bioethanol is not from cellulose. It's from sugarcane syrup. So
Okay.
if you remember the lectures, when we looked at the methods of developing ethanol, the first method was through fermentation, right? Fermentation
Yes,
of sugarcane juice using different types of yeast bacteria. So that is the traditional first generation bioethanol production method. Okay. That basically uses the carbohydrates, but cellulose is a specific enzyme within the woody parts. Okay. And so it's wood to ethanol, if you think of that, or graphs to ethanol kind of a system. So the method is entirely different. So it's second and third generation ethanol production.
Basically, cellulose is a polymer of sir, glucose or fructose. We can say, no, like that only. No? So polymer.
No, cellulose is not a polymer of glucose and fructose. It's cellulose is a different organic chain. It contains glucose and fructose bound in it. The challenge is to break cellulose to take out the glucose and fructose that is bound within. But cellulose is a different structure. It's a large kind of a polymer system.
Right, sir.
Sir,
Yes.
by the way, carbon dioxide production is more. Yeah, when we compare the percentage, carbon dioxide production is more. Is that feasible to pack carbon dioxide from fermentation of sugar? Ethanol factories, yeah. If you consider 50% with carbohydrates, 50%, if I'm remember, yeah. With protein, it may be more, with fat more, with protein somewhere 60% around that one. But for 50% carbon dioxide production is more from ethanol factory in India. How they are handle the carbon dioxide produced from fermentation? Quantity is more. Quantity is more justifiable, yeah, because 50% is more.
Issue is not about the CO2 being produced, because the CO2 being produced is basically what has been sequestered by the plant in that sugar molecule or cellulose molecule or fat molecule, whatever, right? So suppose you are growing sugarcane, it was growing last year, so it absorbed that CO2 last year. And then when you are breaking it down, it is releasing that CO2. So that's why it is supposed to be CO2 neutral in that context. Okay. That carbohydrate molecule or the protein molecule or the cellulose molecule, that carbon is coming from the atmosphere a year back. So that way the net CO2 being emitted to the atmosphere is zero. Whatever was absorbed last year is being emitted in the next year. Okay. And it would have been emitted anyways if it was rotting in the ground. Okay. And bacteria was going to break it down and using it as food. You will again emit the CO2 similarly, right? So the CO2, so that way it becomes CO2 neutral. Of course, the farming process itself may be CO2 intensive. So if you are using some sort of fertilizer, and that fertilizer is being produced in a factory that is burning coal or wood to produce that fertilizer in a furnace, then clearly that fertilizer CO2 input is a positive input, correct? So the entire process may not be CO2 neutral. So there we have to be a little bit careful on figuring out in the entire supply chain up to the point where you are getting your biofuel, what is the net emissions that is not being balanced by the absorption of CO2 by the plant system.
Thank you.
Yeah.
So Sir, I have a question on flywheels applications. I was surprised because light materials have high energy, specific energy density. It is shocking. Fiberglass, everything. Is that applicable for automobiles nowadays? Because when we see flywheels of industrial, they are made of cast irons, big cast irons. Why not they shift to fiberglass? I'm thinking after that.
They should. They should. I am hoping they would. I mean, in high-speed trains, they certainly have. So supercapacitors also does the same job. So in automobiles, many people are using supercapacitors also in regenerative braking systems. So it again becomes a cost-benefit effect, whether you want supercaps or you want flywheels. But in many high-speed regenerative braking applications, flywheels are used. So now exactly where it is used versus what other technological options are there, that kind of varies from one position to another position. But yes, cast iron flywheels are cheap. So when you want cheap, making it very cheap, you don't need that much of energy intensive operations or whatever. Then of course cast iron will be used. Otherwise, for actual good quality energy density, you need to get good materials.
So we expect in the near future new brand vehicles and machinery with fiberglass. Yeah,
we hope so. I mean, there are already, I think, high tech flywheels in many places. I need to check some I gave one example in Germany, but there are other examples also. So I will have to check where they are being used right now. I didn't check before, but in many places these new material high flywheels are being used.
Yeah. Sir, is that due to the development of supercapacitor nowadays electric fuel costs reduce? Electric vehicles costs are now reduced in the world.
The lithium-ion battery costs have also decreased significantly. So EVs, the main cost is the lithium-ion battery. So that has become more efficient. Then their charge-discharge cycles have become better. They are able to store more energy per unit of charge. So those things have helped in making the decrease the cost possible.
Okay, that means previously buying electric vehicle is not cost effective because it needs replacement after 3 years. Yeah.
Yes.
So
yes.
Now fuel cost is low. Now fuel cost is increased. If the battery cost reduce, so now it becomes
EV is
in which direction?
Yes.
Is that better? Is that balancing now in the middle or in our position? Yeah, if because I didn't recommend any person to purchase electric vehicles, I will advise them after 3 years, you may be expected to pay half of the vehicle price. Be ready for that. So most of them are inclined to the fossil fuel. But
true,
now,
but in the US particularly, and I'm also seeing in India, a lot of people are beginning to buy EVs. Because I think the battery technology has gone to a level that you do not have to change it in the 5, 6, 7, 8-year period. And I am not exactly sure what's the economics there, because often especially in developing countries, people want to sell their car right after they're using it for 4 or 5 years. So whether the second-hand car market is favorable for EVs yet, because their battery life is of course low, right? So that may be a concern in the developing countries, that you cannot sell your car with a significant amount of money because the battery system is almost near the end of its life, right? Like a cell phone kind of a situation. So that I am not sure what they are doing, but probably they are giving some warranties that if the battery goes down, within a certain 6, 7, 8 years period, they will replace the battery at low cost or something, which makes the system better. And the range has significantly improved. So many people are beginning to use EVs. I stay in Hyderabad, from where I am teaching in India. And I have seen several EV vehicles now in the road. Almost every day I see 2 or 3. So it's clearly, even in India, it's becoming reasonably popular, especially in the city, urban areas.
Thank you very much.
Thank you.
Sir,
Yes.
in week 9, sir, a term has been used, very low permeable in bracket leak proof hard cabins. Sir, can you explain it more? Is the sedimentary rocks? What is the space? Or is a type of reservoir, petroleum reservoir? How? What
Week
does it
9, which
mean?
lecture?
Sir, so question number 9, week 9, the question has been made on this very
Hold
low
on.
permeable in bracket
Just
leak
one
proof.
second.
Yeah.
Just one second. I need to open the question. Hold on.
Week 9, question number 3.
Yes. So if you don't understand low permeability,
Yes,
just say leak proof.
Terminology, yeah.
Leak proof
Yeah,
caverns.
very low permeable in bracket leak proof.
So
and then hard cavern also.
So you just think of this as whether or not leak proof caverns are desired for compressed air storage system or not, whether that is true or false.
Okay. So some confusion I created, very low permeable in bracket leak proof also. So any
Low permeability means leak proof actually. So yeah.
Permeability means leak proof, sir. Are one thing is permeable means something will pass through it.
Low permeable, but I mean it has low permeability.
Okay. The cavity is a space, sir, below ground. Cavern, the term uses cavity, like
caverns like means caves, underground caves.
Underground caves.
Yes.
They are not filled with either water or a petroleum reservoir like that. They are open spaces.
Caves are always open. Yes, open spaces.
Okay, right, sir. Clear, sir.
Yeah.
Sir, in the remaining minutes, I would like to ask, I was surprised because from the cavern, it is connected to the reservoir. Yeah, reservoir initially to maintain constant pressure.
Yes.
To maintain constant pressures. Yeah. Initially, yeah, what I'm thinking is it may be flooded with water. Yeah, because it is elevation of the reservoir is higher. So during startup, almost, yeah, even the water has a cooling effect. The water has a cooling effect, everything's, yeah. But practically how it is working initially, I think it is flooded with water. Yeah, when the compressed air come, it push out, I think so. How
yes,
the limit
cavern will contain water. As the pressurized air comes in, the water level drops and it goes to some other lake or reservoir that is around it. Okay. So it's usually underground waters are located connected with some local rivers or lakes or something from where the water is actually coming. So when you put a lot of pressure, the water level drops and the excess water goes into other caverns or other lakes or reservoirs. and then as you take out the air, the water rises again. Okay, so so that rise helps to keep the pressure uniform.
What about solubility? Solubility. I'm thinking, yeah, air by itself is dissolved in waters. If it is other liquid, oil type, or in
No,
that
this
case,
is not about oil. This is like very shallow caves, like limestone caves. You know those kinds
okay.
of yes, yes, where people go in sometimes to check where bats etc. live. So those kinds of places. So this is not very deep underground storage. Just limestone caverns or things like that that are close to the ground where you are pushing the air. So oil is not here.
Yes, oil is not there. What I'm
No,
saying
no,
is solubility of air with water, because
not significant. I mean,
no.
air is to some extent soluble, but that is not sufficient. You won't have a significant impact on that.
Okay, okay. Sir,
Yes,
uh, so the remaining 2 weeks, which topics do we cover? Do we need the fuel cells?
we
Everything's,
will go over fuel cells. We will go over hydrogen,
yeah.
and we will go over carbon capture and storage.
What about life cycling? Life cycle
Uh,
costing of everything.
I couldn't cover life cycle this time. It was kind of too extensive.
Okay.
So life cycle was not covered in the last week. I was trying to go to that extent, but I felt that the material was already too big as it is. So I dropped the life cycle for now. But if you are interested or anybody is interested, I can provide some materials that you can look into.
I
So,
will be happier. I am eager to get better material.
okay. My
Personal study.
Yes, you can send me a request on the course with your email, etc. Then I can send some materials for you to study.
Okay, thank you very much for giving me this opportunity.
Yeah, certainly, certainly.
Sir, it will be better some throw light on integrated energy systems also in any of your lectures, in the last one also. Some idea about that. What are the present trends?
On
Integration of,
integrated systems mean all things together.
yeah. Yes, sir. Better
Yeah, the
if you,
lectures are completed. I will check the few walkthrough examples. I tried to give an examples. So full integration, we have to look into that. I haven't made any materials on that aspect as well. In like in the actual offline course, what I give is research projects to the students on the integrated energy systems, how to integrate that knowledge to create kind of a term project kind of a thing. Of course, in NPTEL, it's kind of difficult to do that because those are kind of very specific. So for example, certain example applications are there with some research on how an integration was done for an entire grid or something like that. So that was kind of an extra research material that I give to the students. But here it's difficult. It's an online system. But maybe I can add some materials for further studies near the end of the course. Yes, I think
just
we can do that.
Make us aware what are the latest developments and the things.
Yes, that we can. That I can add. Yes.
Yes, sir.
In the study material section, I can add some things there for people to study. But I will be clear that this won't be part of the final exam.
Okay. No, true, sir. True, sir.
Yes. Yes.
That will be some helpful.
Yes, I will then add a few materials for further study, especially life cycle analysis, integrated research, which I usually give to the course for self-study and guided work. So that I can give, certainly.
Right, sir. Right.
Thank you again.
Yeah, thank you. So the time is up. So if there are no further questions, I will stop today. Good to see both of you here.
Yeah. Thank you, sir.
Yes, thank you.
It's a great interaction with you, sir. So
yeah,
pleasure.
Yeah. Thank you.
Thank you, sir.
And it's a pleasure also. Thank you.
Yeah, thank you, sir.
Okay, thank you, sir. Have a nice day.
Thank you.